In this problem, I'm going to use integer chips to represent and evaluate the product of 2 and -4. So when multiplying 2 by -4, it's helpful to think of this as meaning that you have two copies of -4. So the first number, 2, is the number of copies of things, and the -4 would be the thing that we are copying. So in this example, I need to make two copies of -4, and -4 can be represented using integer chips by just writing 4 negative chips. But since I'm to make two copies, I'll make a second row. Now I'm going to represent the multiplication in symbolic form as repeated addition, and again using the symbolic form for multiplication. So the repeated addition would be that we're taking the number -4 and adding it to itself since there was a second row of -4. So this row represents -4, and we're going to add to it another set of -4. But since I only have two copies of -4, I only make two copies of -4 here. To add numbers of the same sign, you add their absolute values, 4 plus 4, which is 8, and then keep the common sign, which is negative. To write this using multiplication, we would write 2 times -4, meaning two copies of -4 being added, is -8. You may be wondering what would happen if you had a multiplication problem and it was the first number that was negative, not the second. So if I wanted to use integer chips to represent and evaluate -2 times 4, rather than thinking of it as two copies of 4, which was what it would be if the negative wasn't here, we should think of it as the opposite of two copies of 4. So if this represents two copies of 4, then having this sign here means the opposite of two copies of 4. So let's start by making two copies of 4, and then we will take the opposite of that. So the number of copies I want is 2, and the number in each copy is 4. This would be done by representing the number 4, the things that we are to copy, by using 4 positive chips since the number 4 is positive. Since I'm to make two copies, I will make another row. So what I've done is represent two copies of 4. Now what we must do is represent the opposite of two copies of 4. So let me draw a line. The opposite of two copies of 4 would be found by looking at the two copies of 4 here and taking the opposite of that, which would just be the same number of chips except opposite in sign. So rather than having two copies of 4 positives, we will have two copies of 4 negative chips. There's one copy of 4 negative chips. Here's a second copy of 4 negative chips. Now to evaluate the expression, I'm going to start by evaluating the expression using repeated addition. I have 4 negative chips, that's -4, but I also have another set of -4, so I'm going to add to this another -4. If there was another row of 4 negative chips, I would add on even another -4. Each -4 represents one of the rows of the negative chips. When you add numbers that have the same sign, you add their absolute values. The absolute value here would be 4. The absolute value here would be 4. You add them to get 8, but then you take the sign that's common to both. They're both negative, so my answer would be negative. So, turns out, -4 plus -4 is -8. To write this using multiplication, the opposite of two copies of 4, so this would represent two copies of 4, and this is the opposite of two copies of 4, we found that that's -8. I want to do one more example where both numbers are negative. So if I wanted to multiply -2 times -4 using chips, it would be helpful of thinking of the problem in this way. If 2 multiplied by -4 represents two copies of -4, then the fact that there's a sign out here that's negative means that we really want the opposite of this. So we want the opposite of two copies of -4. So let's start by showing what two copies of -4 would look like, and then we'll do the opposite of that. Two copies of -4 would look like this. 4 negative chips represents the number -4, and we want 2 copies of it, so I made a second row. But if you remember, what I've shown here is 2 copies of -4, so that's this here, or in symbols, that's this part of the problem. But we don't want 2 copies of -4, we want the opposite of 2 copies of -4. So the opposite could be described as the opposite of 2 copies of -4 would be take your 2 copies of -4 and do the opposite, which means do basically the same thing except use positive chips instead of negative. So rather than having 2 rows of negative chips, I would have 2 rows of positive chips. So all I've done is take all of my negative chips and change them to positive. Now I'm going to do the problem using the repeated addition method. This row has 4 positive chips, and this row has 4 positive chips. So I have 4 positive chips plus 4 more positive chips, and I would keep adding the number 4 if I had more rows of positive chips. For example, if there was another row of positive chips here, 4 of them, I would add on 4 one more time. Each 4 represents a row of 4 chips. Since I had 2 rows, I only have 2 copies of the number 4 being added together. Well, 4 plus 4 is 8, but remember what this means. That also means that -2 times -4 is 8, because that was the question, and we found the answer to be 8. So using multiplication, we would say the original problem was -2 times -4, and we found the answer to be 8.